This video is all about guided notes and how it can be a fun and interactive way to derive equations in class which foster curiosity and connections. I'm Sid Gunasekaran from Mechanical and Aerospace Engineering, and I'm going to talk about how we can incorporate guided notes into our classrooms which are predominantly math heavy. We all know that in engineering, we derive a lot of equations, and sometimes it can get pretty overwhelming, and students may lose connection between what they are writing in their notes and how it connects to the big picture perspective. In essence, even though our courses are filled with math, what it really is engineering science. And engineering science is the use of scientific knowledge to obtain an engineering predictive capability in order to obtain fundamental physical understanding that can qualitatively and intuitively influence engineering design. And it's very important that when we are deriving the equations, the students understands what they mean every step of the way and how it connects to big picture and how it can influence what they are doing in the subject and how it adds value. And just by copying notes from the board, that doesn't get them there, right? So a solution to overcome the boredom of like students writing down while deriving equations is a guided notes. So here is a derivation example of a math concept. It's called lifting line distribution. It's basically a mathematical way to determine lift from a finite wing. And as you can see, it's pretty math heavy, and there are derivations that kind of leads to a physical quantity, which we call downwash here. And in order to get there, students have to understand various mechanisms or various properties like circulation, downwash, gradients, and all that. And it can be daunting for a student to write all of these equations, especially a big equation like this from the board. And there are obviously spelling mistakes, right, that can occur, or student can misinterpret a symbol for something else. There are a lot of disadvantages to copying things from the board. So an alternative is to take this example and basically cut out few of these equations and even few of the assumptions that goes into the equations and present this to students as guided notes. For example, the same derivation can be converted to guided notes by using this example right here. So as you can see, what I did here is emptied some of the blanks that goes into these steps for students to fill out. So now when students look at these guided notes, they're not just copying the equations on the board, they're critically thinking about what really goes into that box, the empty space right there, and what they need to do to basically fill it out. And if there are connections between this equation, say equation 2, and equation 3, they really understand what that connection means and where it comes from, rather than us instructors making those connections. And when they do this for all of the different processes, all of the different like equations, they truly understand the value of the end result and what it really means. And not only that, they can remember it for a long time, because most students think about where the equations come from, and sometimes the derivations, if they are just writing down, they cannot be very clear. So this will provide a very clear way of obtaining an equation and remembering all the assumptions that went into the equations and all the steps that went into deriving that equation. So some of the advantages are, students pay more attention to the variables in the equations and really make connections between them. Right? And students understand the algebraic relationship better than copying from the board itself. And most students fear math. Every time they come across a PDE or an ODE or even a simple integral, it can be daunting for some students. So by taking the time to write it out, students at least take a step towards truly understanding what that term in the equation meant. And it also fosters interactions and discussions in classroom. If you derive equations on the board and students are simply copying, as instructors know, there is a dead silence. But in this method, students interact with each other and they discuss what goes in the blank. So that way, the class discussion becomes more lively and more entertaining and keeps the students engaged, even in a boring derivation process. Right? And as I said, it provides more structure and clarity, which we all need given the current circumstances. Right? And it does require minimum work from the instructors in the class, because when students are filling out as instructors, we can simply walk around the different tables and make sure that they are they're not stuck, or they are basically progressing through the guided notes, right? But the major disadvantage is requires a lot of effort initially. Creating those guided notes, like writing all of those equations on Word, is a daunting process, especially if the derivation is lengthy. But the good thing is we only have to do it once, and every time we teach it, we can basically use the same guided notes again and again. That way, we don't have to rederive the equations every time, and students can gain a lot out of the derivation process. And one of the disadvantages is also students may get stuck as a group. If they cannot proceed further, then they're simply staring at each other, right? So that's why it's important for the instructor to walk around and provide guidance as to how they can proceed if they are stuck, right? So I have done this in a lot of my classes. I gave out guided notes, and to be honest, it was a fun experience for both students and myself. And as you can see in the top picture, students are deriving equations on the board by themselves, talking to each other, and really understanding like where the equations come from and how they connect with each other, right? And so does you can see the same thing in the bottom picture. So it really makes a more engaging classroom experience, even while deriving lengthy derivations. Right? So I asked one of my students to basically talk about how guided notes helped him, and here's his thoughts.
So I really like the use of the guided sheeting in the class, especially going through the heavy math portion of the class. I think it helps us to keep tracking on what's going on, where the equations from, and then what assumption we make, and then how we're getting through to the conclusion, the final equations. I think it's better than the conventional ways where the professor writing on the whiteboard, and then you might just keep writing down the notes on a notebook, and then maybe you lost the track on what's going on, and just keep writing the notes, and then when you go home, you're getting more confused. While if you have a guided sheet, it's listed clear by the professor, and then it's easy to follow, and then when you go over it at home, it really makes things simple and easy. So, and then when you do the assignment, you know where to look at, what equation you want to use. So it's really beneficial for learning, but it also has its own disadvantage, I think. Whenever a group of students getting stuck on one or two equations, and then they just staring at the equation, don't know what to do, and if the professor doesn't recognize the situation and giving student a help, a little bit of hint to keep everything move forward, then the pace of the class might go really slow. So I think it's a practice on both sides. The professor and the student need to know like what's the best pace of using it. So it's not easy to switch from the conventional class teaching where the professor control all the pace by himself, then to the guided sheet where it's like a group teamwork between the professor and the student. So, but I think that the outcome is really rewarding. I think I learned a lot better than the conventional way. So I really appreciated the way using a guided sheet in class.